Hi, I'm Travis Schwartz, and this is my tutoring video for microeconomics. Today I'm going to be talking about opportunity cost, specialization, and trade. Opportunity cost is how much you have to give up of one object to get one of the other. This is better shown through an example. In this example, we're using inputs. There's two people, John and Lisa, and they're both making bags of potato chips. Or pretzels. It takes John 1 hour to make a bag of pretzels and 2 hours to make a bag of chips. And it takes Lisa 2 hours to make a bag of pretzels and 1 hour to make a bag of chips. In this, you have to know, though, that all other inputs are equal, because otherwise it would not be an accurate thing. So since this is an input problem, you can use the acronym IOU, which stands for input, which tells you this is an input problem, other, under. So let's see what this means. So let's start with John to find his opportunity costs. So for him, 1 bag of pretzels, so you do the other under. So the other is chips, so that goes under. And then pretzels goes on top. So that means 1 bag of pretzels for John is equivalent to half a bag of chips, which means he could make 1 bag of pretzels for every half a bag of chips he makes, or every bag of pretzels he makes, he has to give up half a bag of chips. So now we'll find chips. So you go other on the bottom, so 1's on the bottom, 2's on top. So that means for every bag of chips John makes, he has to give up 2 bags of pretzels. Now we'll do Lisa. So pretzels, so other, under, so 1's on bottom, 2's on top. So Lisa's opportunity cost for pretzels is 2 bags of chips. And then for chips, other, under, so 2's on bottom, 1's on top. So her opportunity cost for chips is half a bag of pretzels. So now to find who should specialize in what in order to trade in the most optimum way, you find who has the lower opportunity cost. So for pretzels, so John's opportunity cost for pretzels is half a bag of chips, and Lisa says 2 bags of chips. So John should specialize in pretzels. For chips, John's opportunity cost is 2 bags of pretzels, and Lisa's is half a bag of pretzels. So Lisa should make chips. Now we have to determine the trade rate. The trade rate is how much each is worth in terms of the other. So to find this, we'll start with 1 on top and 1 on bottom. So we'll do pretzels per chips. So what you do is you find the minimum for each. So for John, 1 bag of pretzels is equivalent to half a bag of chips. So that means that every bag of chips is worth half of a bag of pretzels. So that means 1 bag of pretzels equals half a bag of chips. So then that's the lowest it could be. So the trade rate's in between that and then Lisa's opportunity cost was 2 bags of chips. So for them both to benefit from trade, the trade rate has to be in between these two. If it's here, only Lisa would benefit, and if it's here, only John would benefit. Now to determine to show that they benefit, you have to do before and after for the trade and specialization. So before trade, John creates pretzels and chips, and we're going to say that they have 20 hours each, and we'll split it up evenly. So John would make 10 bags of pretzels and 5 bags of chips. And since the trade rate's 1, they have an equal value. So you can just say he has a total of 15 bags, or the value is 15. Lisa will make 5 bags of pretzels and 10 bags of chips for a total of 15 bags. Now after trade and specialization, John will make only pretzels. So he'll have 20 bags of pretzels, because he can put 20 hours in, so he'll make 20 bags, and 0 bags of chips. And Lisa will make 0 bags of pretzels and 20 bags of chips. So this is their specialization. Now they trade. So they're going to each give up 10 bags. So John's going to give up 10 bags of pretzels and in turn gain 10 bags of chips, because there's 1-to-1 trade ratio. So that gives him 10 bags of pretzels and 10 bags of chips. Lisa's going to gain the 10 bags of pretzels and lose 10 bags of chips, giving her as well 10 bags of pretzels and 10 bags of chips. Add these together and you get 20 for each of them, which is a 5-bag increase from before trade, specialization and trade. You can also use output instead of input for this. So the example for this is now John and Lisa are instead making staplers and cars. So for this, all inputs are constant throughout both, and then you're just determining how much they can make of each. So for this, John can make 200 staplers and 100 cars, and Lisa makes 50 staplers and 50 cars. So this is a good time to talk about absolute advantage, because which is when whoever can make more of the other just blatantly. So for this, John has absolute advantage in staplers and cars, because he can make more staplers than Lisa and more cars than Lisa. But as you'll see, he cannot have comparative advantage in both, because that's mathematically impossible. That'll be proven now. So now for this, you used OOO, which is output, other, over. So what you do here is you take one stapler equals, so you take the other and put it over. So 1 over 2, just dividing each of these by 100. So you get one stapler equals half a car. So that means opportunity cost for staplers is half a car. Then you do the reverse and you get one car is half a stapler, is 2 staplers. And now we'll do Lisa. Since Lisa can make the same amount of staplers and cars, her opportunity cost has to be 1, because for each car she can make the equal amount of staplers. So for one stapler, she can make one car. For one car, she can make one stapler. Now to find the trade rate, we'll do staplers per cars. So the lowest it can be is Lisa's, which is one stapler per one car. And then the highest it can be is John's, which is 2 staplers per one car. The trade rate has to be somewhere in between here. Now let's find out who should specialize in what. So for staplers, John's opportunity cost is 1/2 of a car, and Lisa's is 1 car. So John should make staplers because his is lower. John's opportunity cost for 1 car is 2 staplers, which is higher than Lisa's 1 stapler, so Lisa should make cars. Now we'll do a before and after to show how they benefit from trade. So John will make staplers and cars. So we'll say they'll have double the amount of inputs used to make this chart. So John will have 200 staplers and 100 cars. Lisa will have 50 of each. For this, we'll make the trade rate equal to 3 staplers for 2 cars. So now to find the total value, since they're not equally weighted in terms of trade and their trade value, you have to use the trade rate to determine their total values. So to do this, since every 3 staplers is equal to 2 cars, you can multiply the number of staplers by 2 and the number of cars by 3, giving you a 400 plus 300 or 700 total value in terms of trade. And then you can do the same for her, and you get 250 total trade. Now we'll do after specialization and trade. So with specialization, since John's making staplers, he'll make 400 staplers and 0 cars. Lisa will make 0 staplers and 100 cars. John's going to trade away 150 staplers and get 100 cars in return, because the trade rate's every 3 staplers is 2 cars, so divide this by 3, you get 50 times 2, 100. So he'll finish with 250 staplers and 100 cars. Lisa will gain the 150 staplers and lose all of her 100 cars. So she'll finish with 150 staplers and 0 cars. Now we'll find the total value again. And we'll get that John has 100 total value, which is 800 total value, which is 100 more than he started with before specialization and trade. And Lisa has a 300 total value, which is 50 more. So as seen here again during input and output, specialization and trade benefits both people involved.